So as you can see, what have I got here? First up, there's the sum of roots, right? Alpha plus beta plus gamma, and taking the negative over the other side, minus b on a. Now you're starting to see why sum and product of roots is not quite a good enough way to describe when you're going for polynomials, okay? Because this is the sum of roots, and looking on the end there, you've got the product of roots, which is minus d on a. But what's this guy? What do you call him, right? He's not the sum, and he's not the product.
He's a conglomerate.
Yeah, so what we say, the way we describe this, which is C on A. If you want to say this generally speaking, okay, because it should look suspicious to you. You're like, this is exactly the same thing that we got with the quadratic, right? Minus b on A, right? These first two coefficients here, they're always going to be equal to the sum of the roots, but more specifically, you say taking them one at a time, right? Hence alpha plus beta plus gamma plus delta plus however far you want to go, right? When you move up one, C on A, and please watch out for the negatives, okay? Everyone always screws that up because it's easy to forget that it's there or it's not there. C on A is still the sum of the roots, sort of. It's the sum of the roots two at a time. Okay, so in this case, it's alpha beta plus beta gamma plus alpha gamma. But, for instance, if we had a quartic, power of 4, not power of 3, right? There would be many more combinations, right? You'd get alpha beta, alpha gamma, sorry, bad gamma, alpha delta, then you'd get beta gamma, beta delta, you're going to get gamma delta, and wait, is that it?
Yeah.
Is that it? I think that's it, right?
Yeah.
Now I got them all. So you just got to be careful and methodical in the way that you write them out so you catch everyone. But that'd be C on A if it was a quartic. And minus D on A is the sum of the roots 3 at a time.
So you just say everything is the sum of the roots.
Okay? Yeah, they're all different kinds. But you see, for instance, if we were doing a quadratic, right? Sum of the roots 2 at a time, well, there are only 2 roots. So it's just alpha beta. So we would call that the product of the roots, right? And for the cubic, the sum of the roots 3 at a time, well, there's only one way to combine them in 3. You've got to take all of them and take the product, right? So that's why this would be the product of the roots for a cubic, okay? So obviously, this pattern, which is really kind of neat and interesting, and this is what this guy proved, it generalizes for all polynomials, which is kind of strange. So